All right, now what we're looking at today are scatter plots. Scatter plots are a graphical representation of points, just a bunch of points. We don't have a line. So if we just have points, we use a scatter plot. And a scatter plot is a graph that shows the relationships between two data sets. The data sets are graphed as ordered pairs in a coordinate plane. Scatter plots can trend in the data. So they can trend in the data. That means they're kind of either all going up, they're all going down. There's a trend as to how the data flows from one to the other. Now the first scatter plot that we look at shows the amount X in grams of sugar and the number Y of calories in 10 smoothies. So it's looking at 10 different smoothies and the amount of sugar it has in grams compared to the amount of calories it has. So the first part, how many calories are in a smoothie that contain 56 grams of sugar? So our grams of sugar is X. So if it's an ordered pair, X is always first, Y is second. So looking at that chart, where would we go to find the grams of sugar? Would it be the horizontal, up and down, or left and right? Horizontal, because it says sugar down there on the bottom of the graph, yes? So I'd go over to 56. Well, 56 is about in between this here, because it gave us 54 and 58. It didn't give us exactly 56. So I go to about where 56 and go up. Well, we do have one point that's at 56, yes? So how many calories does it have? So to be the point 56, 270, there's 270 calories in it. And that's it. That's all we have to do for A. Any questions on that there? Any questions on the first one? Okay, let's look at the next one. How many grams of sugar, so it doesn't give us the X value, that contain 320 calories? Well, that's our Y value. So 320 calories, well, there's only one point at 320, yes? Well, how many grams of sugar would it have? We would go straight down, and that's at 70. So 70 grams of sugar. So that would be at the point 70, 320 calories. So 320 calories, it has 70 grams of sugar. Any questions on these two here? Now, what trend happens to the numbers as the number of calories trends to the number of calories as the number of grams of sugar increases? As we increase the grams or the amount of sugar, what's happening to the calories? It's going up, yes? Would the data on this chart, would our scatter plot prove this? Would it show that this is increasing? As sugar increases, calories increase because it is increasing. Yes. Okay. So again, we still have grams of sugar and calories. How many calories does 51 grams of sugar have? Well, we have 4 different points, yes? Which one of those points would be closer to 51? I would say 260, yes. Yes. Because 51 is going to be closer to 50, it's going by scales of 4. It's looking like it'll be closer to that, because the point at 250 Looks like it's closer to being exactly between 50 and 54, or closer to the middle. So that'd be 260. Okay. Any questions on any of this here so far? You like this so far? Now the second part is asking how many grams of sugar in the smoothie that contains 250 calories. So 250 calories is our y. So how many grams of sugar would that be? So it's this point right here, yes? Well, again, that's kind of close in the middle of those two. So I would say 50, what? What do y'all think? Here. I think 52, because it's about right there in the middle, isn't it? Yeah. And that's it. Questions on this here? Any questions on any of this here so far? We good with this here? Okay. Now, correlation is a relationship between the sets of data. We can have three different types. We can have a positive correlation, a negative correlation, and no correlation. What we consider it positive is if it's going up and the points are close together. We can draw a line and all the points stay closely around the line. A negative correlation, again, the points are staying pretty much close to the same. If we draw a straight line, it's going down. Well, looking at this here, is there any way to draw a line where most of the points are contained? No, so it has no correlation because there's no real symmetry or relationship to how the numbers are flowing. So positive correlation, they're real they make a line, we can see a pattern, we can see a trend, and it's going up. Negative correlation, they're kind of, again, making a line, staying close to a line, and they're going down. No correlation, there's no real grouping to how the data is. It's just all over the place. Okay, well, let's look at the next thing. Tell whether the data shows a positive, negative, or no correlation. I would agree. Because there's no real correlation to this here, how it's going up, how it's going down, because everything is too spread out. How about the temperature and coat sales at a store? This here would be a negative correlation because as the temperature increases, the amount of coat sales goes down. Any questions on these two? Yeah. How about stopping distance? Positive, because again, the numbers are pretty close together. We can draw a line, and it's going up. So the faster you go, the longer it takes to come to a stop. Or I would say a controlled stop. Tell whether there's a positive correlation comparing the birth months and sleep. There's no correlation here. There's no real organization to the amount of sleep in the month that you were born. Questions on this here? You kind of like this? Okay. Now that line that I was drawing for the ones for positive and negative correlation, that line that we can see the data follows around, that is described as the line of best fit. Okay, I see that. Yeah, so that there, yep, I'll have two, let's pause. Okay, so we're given this data here. So really what we would do is we would plot the points. And if we look at this here, is there a positive, negative, or no correlation to this here? This here would be positive, because even though we do have a few kind of outliers, we still have that positive trend. There's still a overall positive trend to this here. And this here is the other set of data. And again, this here would be negative because they're going down. So it'd be negative because it's going down. Any other questions on this here? It would be no correlation, because when we talk about this here, this line of best fit, it's either going to be increasing or it's going to be decreasing. Now, they really wouldn't deal with, I mean, we could still have a function that does it, but it wouldn't be linear. It would actually be more kind of quadratic, a shape like this here. And we can do a line of best fit for it, but it's not a linear function. And we can have higher degrees because we could actually have line of best fits that fit different types of graphs, but it's going to be higher degree. And we won't talk about those here. So when we talk about a line of best fit or making a line of best fit, the first thing we want to do is we want to make a scatter plot of the data. We actually want to plot the data points. Our second step is to decide whether the data can be modeled by a line. Is it a positive or negative correlation? It has to be one of the two. If it's no correlation, we cannot have a line of best fit. And then we want to draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. So it wants to be kind of in the middle. And then we want to write an equation using those 2 points. So the first thing we have is this here. So we have this table here. Now I created a table here also because I ended up getting one. There isn't one on your paper. So the week sales, 1. So we have 119, which would be about right here. Our next one is 215. Yeah, a little bit farther over. So 119, 215, 313, 411, 510, 68, 77, and 95. So if we were to plot this here, this would be about our points. Well, not about, these would be the points. And so what we want to do is now kind of plot a line of best fit. So I kind of want to draw a line kind of through these points where we'd have about the same number above it as below it. Let's see here, straight line. So with this line here, have about the same number above it as below it. Because how many do we have above the line? 3. How many do we have below it? 3. And so we try to go through 2 points so that there's the same number above and below it. Now, one of them we went through was 5, 10, and the other that we went through was 1, 19. Well, we try to make it so that 2 points, we go through those lines. We want it to go through 2 of those lines. We want the line to go through 2 points. Now, the slope is rise over run. So how far did it go down and over to get to this point? So how far did it go down? It went down from 19, because it went from 19 to 10. So we went down 9 and over 4, because we went from 1 to 5. So the slope would be what over what? Negative 9 over 4. We call it negative 9 because we went down 9. Down is negative, and we went to the right 4, and right is positive. So our overall slope for this here is what? 9/4. And again, what we're wanting to do is create an equation of a line. So I have a slope and a point, yes? I can use either one of these here. And our point that we can use is, say, 5, 10. And we're going to use our y minus y1 equals m times x minus x1. Now our slope was negative 9/4. The y value, so x1, y1. So the y value is 10 and the x value is 5. Now what we can do is we can multiply through by our negative 9/4, and negative 9/4 times x will be negative 9/4 x. Negative 9/4 times negative 5, well, the negative and negative would make a positive. Well, this gives us 45/4 if we multiply it. Because 9 times 5 is 45 over 4. So these numbers aren't nice. In most real-world examples, we don't get the nicest numbers. And to get our final equation, we have to add 10 to both sides because we want y by itself. And this here is an equation that will closely represent the data, hopefully. But that's it.